Let P be a point on the graph of y equals to negative x squared minus 4. All right, let's look at part A. It says, express the distance d from P to the point 0, negative 2 as a function of x. All right, so we're trying to find the distance from the point P to this point 0, negative 2, and we want to express that as a function of x. So the way we're going to do this is basically to start with a geometric formula for distance. So that's our first step always, is to actually go ahead and work with the geometric formula and see how we can use that to kind of come up with an expression that we can then substitute in the other function that was given to us. All right, so starting with d as the distance formula, we know that that distance formula is the square root of, and basically you have two parentheses squared added together. And in the two parentheses, you basically have the differences between the x components of the point and the differences between the y components of the point. So let's start with the x components of the point. The point P is just going to be x and y. So I'm actually going to put those in the front positions, x and y, and then we subtract away the y and x component of the point, right? So let's start with the point here being 0, negative 2. The x part of that is 0, so I'm going to pair that up with the x here in the first parenthesis. And in the second parenthesis, I'm going to put the negative 2 in. So we'll have two negatives in that parenthesis then. All right, from there, it's just a matter of doing a little bit of arithmetic here. So we'll have the square root of x minus 0, of course, just gives you x, and that'll be squared, plus it'll be y plus 2, right? Y plus 2 quantity squared. The plus because we have the double negatives here in this parenthesis. All right, from there, we can actually expand out that y plus 2 squared statement, right? So if we want to expand that, we'll end up having the y squared, right? When you square a binomial like this, the first term is squared. Then you end up with twice the product of the two terms. So 2 times y is 2y, right? And then double that is 4y, so we'll have plus 4y. And then, of course, 2 squared gives you 4. So that will be the full binomial squared. Now from here, we've done what we can with the distance formula, but we need to now get rid of the y because they asked us to express this distance as a function of x, right? So as a function of x means that we can't have any y's in our statement. So we need to now substitute for y. All right, so we'll have d is equal to the square root of x squared plus y squared. Now for the y squared, we're actually going to plug in what y is equal to according to this function. That'll be negative x squared minus 4. That guy is going to be squared. And then we'll have plus 4 times y. Now y here is negative x squared minus 4, so we'll plug that in. And then we have plus 4 at the end. All right, so we're basically using this, and we're plugging in y wherever we see a y in that statement, right? And y, again, is negative x squared minus 4, according to the problem. Okay, from here, it's just a matter of cleaning that up. That's not so simple. We have to actually expand, right? So we're going to go ahead and say that we'll have the square root of x squared. And then if we want to expand this binomial, remember you square the first term. That'll get rid of the negative and make it x to the fourth. Then you actually take the product of these two terms here. So negative 4 times negative x squared is going to end up giving you a positive 4x squared. And then you do double of that to give you positive 8x squared, and then you have plus 16 when you square the minus 4. Then you're going to distribute in this positive 4, so it'd be 4 times negative x squared, and 4 times negative x squared is going to give you negative 4x squared, and then 4 times negative 4 is going to give you negative 16, and then you have that plus 4 inside the parenthesis. Okay, continuing with the simplification, we're going to go ahead and combine like terms under that radical. So we can see that the 16 will cancel out with the negative 16, so that goes away. That's nice. And then we can see that we have a bunch of x squareds, right? We have 1x squared and 8x squared. That's 9x squared. Take away 4 of those x squareds, you end up with positive 5x squared. So we'll have a plus 5x squared under the radical. I have a positive x to the fourth, which I'm going to put first. And then finally, we've used up all the x squareds, and we've used up the x to the fourth. We canceled out the 16s, and we're just left with a 4 at the end, a plus 4. Okay, so we finally have our expression. It's not the prettiest expression in the world, but that is the answer. that's the distance basically expressed as a function of x. And this distance is the distance from this point P to the point 0, -2. All right, remember P is a point on that original function that we had in red above, right? So this function here, P is some point on that function. Now what they're asking us to do in part B is to say, great, we have this function now, which is a function of x. Can you now tell me the distance from P to the point 0, -2 when the x component of P is -2? So they're basically asking us in part B to go ahead and plug this x value that we were given in the statement into our function. Well, that's easy enough. To do part B, and let's go ahead and label these parts. This is part A, and then this will be part B. To do part B, all we have to do is plug in that -2. So we'll say that the distance is equal to the square root of x to the fourth, that'll be -2 to the fourth power, plus 5 times -2 squared, plus 4. And of course, when you evaluate that, you'll have -2 to the fourth, which is 16. Remember, the negative will become positive because of the even power. Then you'll have 5 times -2 squared. Well, that's the same as 5 times 4, or in other words, 20. And then we'll have plus 4. All right, so that gives us a final answer here for the radical of 16 plus 4, which is 20, plus 20. That gives you 40. All right, so the square root of 40 is the arithmetic, and then if you want to clean that up just a little bit, we like to simplify by saying, that's 40 is the same as 4 times 10, and so we'll have the square root of 4 times 10, and then, you can take the 4 out as a 2. So we'll end up saying that the distance is then equal to 2 square roots of 10. Now, if you want to actually check this answer, what you can do is you can actually plug -2 into your original function here in red, see what the point is when x is -2, and then take that answer and use the point they gave us, 0, -2, and plug them into the original distance formula. You will see that you get the same answer, 2 square roots of 10, as the distance.